So in 3.2, we are talking about function operations. So we're taking functions and we're doing operations with them. So like adding and subtracting, multiplying, dividing, so all the functions or operations that we're used to. However, there's one more operation we're going to learn about, and that is composition. But we're going to start with the ones that we are used to seeing. So how this works is you will be given two functions, and they'll have two different names. So like for us, it's f of x and g of x. So we're going to be creating a new function. So find each new function and state its domain. We'll talk about domain a couple times. I'm not going to do it on every single one of these, but we'll practice it. So finding each new function. So here we're given f of x and g of x. They are two different functions. And then here we are told what we are supposed to do with it. So this looks kind of weird. This is f plus g of x. This is not timesing by x. Please don't make that mistake. That happens so many times. This is not times x. The same as this is not times x. This is not times x. It is f of g, or f plus g of x. Another way of writing this is f of x plus g of x. So that this right here is the same as what I just wrote over here. So all I have to do is I have to take my new functions and plug them in, or take my old functions. So f of x is, we're going to replace with what f of x is equal to, which is x squared plus x. And then we're going to add g of x, which g of x is equal to 3x minus 1, as shown above. F of x equals this, g of x equals this. So I plug those in, and then I just simplify. So it's just addition. So you can think about distributing your plus sign or the 1, but that doesn't make a difference. So we can just get rid of our parentheses and then just simplify what we can. Combine like terms, it's just addition. Don't freak out because there's parentheses. So combine like terms, so x plus 3x gives me 4x minus 1, and there is my new function. That is my answer. Totally simplified. I just added my new functions to create a new function, and that is what I got. And that's it. Okay. We're going to come back to domain, so don't think I forgot about it. Okay, so x squared plus 4x minus 1. Now we have a new one. Over here, we're doing f minus g. We're using the same f and g, however. So again, another way of writing this is f of x minus g of x. So this time we're taking our f function, which, fill it in, x squared plus x. Please always put them in parentheses because it makes a difference, especially on this one. So minus, and then we fill in g of x, which is 3x minus 1. So it's important on this one because we have to make sure that we are subtracting all of g of x. So now when we simplify, I do have something to distribute over there. So the negative, distribute the negative, that becomes minus 3x and plus 1. So now when I simplify, x minus 3x, those are like terms, so I can combine those to get negative 2x plus 1. So there is my final answer for that function. I just minused them and simplified them. So there's our answer there. Here's a new one down here, using the same f of x and g of x once again, but this time it's multiplication. So again, this is the same as f of x times g of x. And our composition is going to look very similar to this, but so just know that's a dot. Multiplication is a dot. F of x, let's plug that in parentheses, so that's x squared plus x, and then my g of x is 3x minus 1. So now I'm going to simplify, so you can set up your box over on the side. I'm going to do that, or you can just do your foiling, x squared plus x, 3x minus 1, multiply everything together, and pause this video anytime you need to so that you can do the work and then check your answer afterwards. It's always better to try it yourself first and then go from there. So that equals 3x cubed. Combine like terms, so we get positive 2x squared minus x. And that's my simplified function. And then we have one last operation using those same two functions. So this time we are dividing. And don't forget, because dividing is sometimes more tricky than other things, but in this case it's not going to be. So I'm going to put f of x on top, g of x on the bottom. So here we go, we do x squared plus x, 3x minus 1, and then we're done. The end. That is it. Yes, that is it. Okay, now going back to domain, domain refers to x values. You should have talked about domain so many times throughout secondary 1, 2, and 3. Domain always refers to our x values. So when it's asking for domain, it's asking what x values am I allowed to plug into these functions. So the only times that we are not allowed to plug numbers in, so our domain restrictions, this only happens when I have a square root, because I'm not allowed to have negatives underneath the square root, or any even root for that matter. It happens when I talk about logarithms, which we haven't talked about yet. You will not see those today, so we won't worry about it. And it happens when I have a fraction because I'm dividing. So when I have a denominator, means I'm dividing, and there is a number that I am not allowed to divide by, and that number is 0. So my denominator is not allowed to equal 0. So unless I have one of those three things, one of those three restrictions, then I'm okay. So this domain would be all real numbers, and then R with 2 lines on the side, that represents all real numbers. Or you can write it as negative infinity all the way to positive infinity. That means the same thing. Okay, this equation does not have a square root or a logarithm or a denominator, so my domain over here is also all real numbers. Same thing over here for my multiply function, all real numbers for my domain. But down here, I have a denominator on this one. So I just have to set up this equation just like it looks like right here. So I say my denominator is not allowed to equal 0. And then I solve it. So add 1 to both sides, plus 1, 3x. We'll zoom in so we can see it better. And make sure it's cannot equal, not allowed to equal. Then I divide by 3. So x cannot equal 1. And that right there is my domain. X can be whatever it wants. Ooh, 1/3, sorry, missed it. Can be whatever it wants, except it cannot be 1/3. And that is my domain. So that's really the only issue you have to worry about with domains, is the denominator. If we ever come up with a denominator, that's going to be a restriction. Okay, that's all the addition and subtraction practice. And we're going to jump right into composition. So what composition means, you will see it written like this. And hopefully you see why I brought up the fact that this is not multiplication. This right here is a circle, not a dot. So make sure you know the difference. This is composition, which is not multiplication. So make sure you know the difference. So how we read this is G of f of x. I'll write that out. G of f of x. So it's a lot of ofs, okay? Another way to write that is this. So really what we're doing is we're taking our f function and we're plugging it into our g function. So again, that second function right here, we're taking it and we're plugging it in to the first function, the g function. So just how you see sometimes, like if you're given a function, for example, like f of x equals 3x minus 4 or something like that, and you're asked to find f of 2. That means we take this 2 and we plug it into our function. So we do 3 times 2 minus 4, and we simplify and get our answer, like so on and so forth. So anytime you have something inside, you plug that into your function. So we're going to do the same thing, except this time it's going to be an entire function that we plug into another function. So let's get some practice on that. Okay, so functions inside functions. Oh, and we have a number. There we go. So we've got lots of practice to do. So we're going to evaluate each thing. So I'm going to rewrite this because this is the same as f of g of 3. So I'm going to start at the very inside because there's a lot of ofs. Parentheses come first, order of operations. So I'm going to take the 3 and I'm going to plug it into the g function. So let's just figure that part out. So looking at our g function here, let's plug in a 3. So over on the side, I'm going to do g of 3. And that's going to equal, instead of x plus 1, we'll plug in a 3 plus 1. And that equals 4. So now I can take this g of 3 and replace it, because I evaluated it, I figured out what it actually equals. That equals 4. And so now I'm going to take this 4 and I'm going to plug it into the f function. So you're taking one answer and you're plugging it in to the second function. So this time let's look at our f function. So the absolute value of -2, but instead of x we are plugging in a 4. So here we go. So the absolute value of -8. And remember, absolute value is just asking about distance. What is the distance from 0? So we drop the negative, the distance from 0 is 8. So start on the innermost parenthesis. If there's a number there, you've got to plug that in. And then go from there. So my final answer for that one is 8, because I had to plug in a number. Okay. So there's our final answer. Okay, we're going to do a similar thing, but this time we're doing g of f of -5. So I won't rewrite it because I know what I'm supposed to do. I take that number and I plug it into the function right next door. So f of -5, let's do that first. So f of -5 equals, here's my function, -2 times -5 instead of x. So I'm plugging it in up here. -2 times -5 is 10. Absolute value of 10 is 10. Okay, but I'm not done. I just figured that out, so now I'm going to take that number, what I found out from here, and I'm going to plug that into g. There's one more step. So now we do g of 10. So instead of x plus 1, it's going to be 10 plus 1. So my final answer is 11. So again, one step at a time. Okay, so on this one we have 2 new functions. Same idea, pause the video, try it out yourself first, but you take this number and you plug it into g, and then whatever you get for your answer, you plug that into f. So let's start with g of 9. So g of 9, we have a square root this time. Oh, we might have more domain restrictions. So g of 9, we plug in a 9 minus 4, which gives me the square root of 5. I cannot simplify that, so I'm just going to leave it as the square root of 5 and call it good. So now I found my g of 9, but remember what I have to do is I have to take that answer and plug it into f. So let's go for this. So we plug it into f. So instead of x squared, I'm going to have the square root of 5 squared plus 5 times, instead of x, I'm going to plug in a square root of 5. So this gets plugged in 2 places because I have 2 x's in f of x. And then I simplify. So the square and the square root cancel each other out. 5 times the square root of 5 is just square root of 5. You can come up with a decimal for that one, but that is also considered simplified. So there's our final answer for that one. You do not always have a number to plug in, but sometimes you do. Let's see if we have an example where we don't. So this one, take your 7, plug it into f, take that answer, plug it into g. Go ahead and try this, and then I'll pull up the answer. Okay, his answer for that one is 4 times the square root of 5. Or if you had the square root of 80, that is also true. Just 4 times the square root of 5 is simplified, if you remember how to simplify your square roots. So you take the 80 and you break it down. 2 times 40, you keep breaking it down. 2 times 20, keep going. 2 times 10, keep going. 2 times 5. So you look for all of your pairs of numbers. So I have 2 pairs of 2. So I have a 2 that gets to come to the outside, another 2 that gets to come to the outside, and then the 5 does not have a partner, so it is stuck on the inside. So that is how we get 4 times the square root of 5. Okay. All right. So now in this case, we do have an example where we do not have a number to plug in. So we're just going to take this whole g of x and plug it into f. We only have one step. So this, if pictures are helpful for you, so if you think of f of x as a pizza, g of x as a pineapple, here we're taking g of x, which is our pineapple, and we're putting it into f, which is the pizza. So this is putting a pineapple into a pizza. But backwards, if we take f of x, put the pizza into the pineapple, that is what it looks like. So that's the difference, if you like pictures. Okay, so what we do over here, we just take g of x and we plug it into f of x. So we take this whole thing of g of x and we plug it into our variable for f of x. So instead of x plus 7, I'm going to replace that x with x squared minus 4. And then we have our plus 7. And then you just simplify if you can. So x squared minus 4 plus 7, we combine like terms, and we get x squared plus 3. Okay, another example, if we take the same function and we plug f of x into g of x. So you're taking this whole function and you're plugging it into this x. So here we go, I'm going to write it underneath. So f of x, oops. So instead of x squared, I'm going to have the whole x plus 7 squared. And then minus 4. So in simplifying this, remember you have to FOIL it. So x plus 7 times x plus 7, I'll do that over here on the side. Combine like terms, so I get x squared plus 14x plus 49, and we still have our minus 4. Okay, combine like terms, simplify, and that is our answer. The trickiest part, you've done all the simplifying before, the trickiest part is practicing plugging one function into another function. So knowing where to put it. So really, you just look at your function and you just erase the x wherever it is and replace it with everything in the other function. That's kind of how I visualize it. Okay, let's see if we can figure out this guy. So we have different types of functions here, but that's okay. So we're going to take g of x, plug it into f of x. So we're going to take all of this, plug it into the variable right there. So that turns out to be 3 minus x over x plus 1. So the only way to simplify this is to get a common denominator, and 3 over 1, so we don't have anything common yet. So I need this x plus 1 to show up on the bottom over here. So remember how you do that. You have to multiply top and bottom by the same thing. So we're going to multiply top and bottom here by x plus 1. This is going to come up in the next unit, so that's why we're practicing this. So I'm going to distribute that 3 to everything up there, 3x plus 3 over x plus 1 minus x over x plus 1. Okay, now that we have a common denominator, we can combine. So 3x minus x are my like terms, so I come up with 2x plus 3, and my denominator stays the same. Okay, and then last one. We're taking f of x, plugging it into g. So we take f of x, and we plug it into g. But here there's 2 places, there's 2 variables to put our f of x. So make sure you're careful. So I got 3 minus x on the top, and then I have another 3 minus x on the bottom, and then I still have my plus 1. So then we simplify. 3 minus x, we have like terms on the bottom, so that will be 4 minus x on the bottom. And that's as far as we go.